Welcome, everybody, in Happy Time Zone. Thank you for joining us today for Kyle Avery's first webcast with us. It's abusing Microsoft Office for post-exploitations.
I'm kind of blown away by this webcast just because the attendance, we kind of blew some records here on getting people to register. More than 2,000 people have registered for this. And so, Kyle, guess what? You're coming back next week. Kyle is also a tester. His training class, it's going to be great. It's such a great opportunity. And with that, I wanted to remind everybody that we do, when you purchase a training class through Anti-Siphon Training, Wild West Hackin Fest, 10% of the revenue goes out to a charity of the instructor's choice. So not only are you helping yourself by learning with our training class, you're also helping people in the community or people who are less fortunate and need help. We have some great nonprofit organizations. Have you made that selection yet, Kyle?
Yeah.
Do you know where your money's going?
I did, yeah. So I want that to go to the Innocent Lives Foundation. I think they were actually on one of our roundups a few months ago, and that was when I first heard about them. But I just really like their sort of goal of catching these predators, right? And also just the way that they're able to use their security knowledge to sort of do that was really interesting to me. And so that was kind of where I wanted to go.
For those of you who have taken training with us, in Q1, we were able to donate $21,000 out to different organizations to help support their efforts and their causes. So again, not only is taking training with us a great opportunity for you, like we like to say, it's quality, it's high quality training at an affordable price, but we also like to help other people in the industry.
All of our trainings are actually recorded, and they're available for you for 6 months after the class. Along with that, you also get 6 months access to our cyber range. And Megan, I don't know if you want to mention a little bit more about the cyber range.
What our vision is with our cyber range is we know that there's a huge skills gap, and we want to make sure that people are not just learning the information in class, but they're able to put it to practice and use. So there are different levels that you can get. ACE-T certification is something that we're actively launching for the community so that people can show their skills to potential employers, or just kind of have bragging rights with your friends, like recon, pen testing, forensics, crypto, threat hunting. If you take a full price class, you get access for 6 months. If you take one of John's Pay What You Can classes, as long as you pay above the $195, you get access as well. But if you just want to check it out for a month, you can do that too. It's $30 monthly. This year, we are releasing at least 5 new challenges to the cyber range every 2 weeks.
Kyle, can you talk a little bit about your training class? Just kind of give a brief overview on your upcoming training.
It's all around Windows post-exploitation. And so what I mean by that is we're going to talk about kind of everything that happens after you get your initial shell in some environment. And so we'll go over enumeration, persistence, privilege escalation, and lateral movement. And so for each of those 4 categories, we're going to talk about kind of what the different popular methods are that you can use to achieve each of those, and then also what the sort of implications are in the environment. And so that way, when you get into that situation, you know how to select a technique to use based on the detection capabilities that you've seen in the environment. And so my hope is to kind of give you not only just a list of tools and techniques that you can use, but also kind of the skills to choose which one you'd like to use in a certain scenario.
From being a non-technical person, Kyle was kind of explaining some of the things, and I was like, I actually understand what you're saying. So I know you're going to do a great job with your training class, and I know that anybody who elects to take it is gonna come out a very happy camper. If you'd like to learn more about Kyle's training class, please visit our website at wildwesthackinfest.com. It's under the anti-siphon training tab. There's a drop down. You can go in and take a look at Kyle's training, as well as all of the training offerings. We got some great things happening. Joff Fire is teaching, Michael Allen, Carrie and Darren Roberts, Alyssa Torres is joining us, which we're super excited about.
Today, we're going to talk about abusing Microsoft Office for post-exploitation. And so, quick kind of introduction. So my name is Kyle Avery, and I'm a pen tester with Black Hills Information Security. I also work on a couple different projects there to aid in our .NET tool usage. I posted my Twitter and GitHub there, so feel free to follow those if you'd like. As far as our agenda for today, my goal is to talk about three different sort of areas of post-exploitation. So we'll talk about persistence, lateral movement, and credential gathering. And for each of those three categories, we will talk about how you can use Microsoft Office to aid in your process for each of those. Just a quick background. If you're not familiar with Microsoft Office, it's a productivity suite of tools, right? You've got Microsoft Office Word, Excel, PowerPoint, and they're all just tools made to help average users, not necessarily technical people, do their jobs, right? And so Microsoft Office is very commonly used in corporations. Every corporation that I've ever tested uses Microsoft Office. I'm sure that at least a majority of the corporations we test at Black Hills use Microsoft Office. And it's very standard to install that in a sort of golden image or just on every workstation that you have in your environment for the most part. It's not something that's necessarily part of the core Windows install. So, or maybe there are better techniques in certain scenarios for when workstations don't have Microsoft Office installed. But it's something that's present often enough that it can be a useful sort of set of tools for you to have as an attacker. And as a defender, if you're deploying Microsoft Office, it's probably good to know these sorts of things attackers can do with it. Now, I am going to touch on, for each of the different techniques I talk about, I'm going to kind of have a kind of summary with detections for each section. And I'm not someone who writes detections for a living. I'm primarily a pen tester. But my hope is to kind of give you at least a starting point of where you might look from a detections point of view, and to kind of give you an idea of what detections already exist in Windows to sort of prevent these things from happening. So Office is probably most famously used for initial code execution, right? There's, I guess, a very common scenario where users are sent a Word document or an Excel spreadsheet, and it has an embedded macro that will execute some kind of connection back to the attackers. And this can be done with some kind of social engineering pretext that gets them to open it and gets them to click to enable macros or enable content if necessary. And so this is a great use of Microsoft Office, don't get me wrong, but it can also be used for persistence, moving laterally, and gathering credentials. And that's kind of what I hope to talk about and to kind of show you that Office can be more than just an initial code execution vector. The first thing I want to talk about is persistence. And so persistence is really just the act of maintaining access to a system. And so this, ensures that you don't lose your access on an endpoint, right? You don't want to lose your access to that endpoint. You don't want to lose access to the environment as a whole, or even just a specific privilege level, right? If you've compromised a user that's at a certain privilege level, you want to make sure that you persist at that level. And you want to make sure that you maintain that access if your session dies for any reason, whether that's the user rebooting or logging out, or if there's some error with your code or whatever happens, right? I listed the MITRE attack IDs for the techniques that I'm going to be talking about in case you're interested in that. You can kind of look up their kind of recommendations for those things as well. So first of all, I want to talk about Word WLL add-ins. So Word in the totally default configuration on just a default Windows machine references what are called trusted locations on Windows. And these trusted locations can be enumerated at that registry key that I listed there. The only thing that might change is the number 16.0 there, and that indicates the version of Office that you have installed. And so that's for Office 2016, for example, which is what I had in my test environment. And then Word there, if you want to query trusted locations for other applications, you would change Word to say Excel or PowerPoint. You can query trusted locations there at that registry key. And if you place a WLL file in one of these directories, it will grant code execution to you on startup. And this is pretty interesting, right? But you're probably wondering, okay, what's a WLL file? Because at least I had no idea what a WLL file is, and I keep having trouble saying it. But all that is it's a DLL, or at least all it has to be is a DLL that's renamed with a new extension, WLL. And so you'll place whatever code you want to execute in the process attach block, which I'll show you in a second. But basically, you can just generate a DLL, whether it's a C# project DLL or an unmanaged like C++ DLL, or you can just write one and then export it, or build it and then rename it to .wll and place it in one of these trusted locations. Now, one thing that's important to know is that Excel actually has trusted locations that will execute XLL files, which again is just a renamed DLL. And XLL files will not be executed by Excel at startup in the default configuration like Word will. And so for Excel, you have to make a registry change to enable these XLL add-ins to be loaded by default. And so in most scenarios, I think Word add-ins are probably more useful, right? Because they don't require as many changes to the system in order to get them to function. But if the environment's already using XLL add-ins for whatever reason, or if you've seen that maybe registry changes to sensitive locations don't get alerted on very often, it could also be a good technique for you to use. So I figured, it's probably best to include it, if only so you have some idea of what kind of techniques are out there. Moving on, this is just a couple screenshots here of a very basic DLL that you can use for this process. On the left, that is just the kind of boilerplate code that gets generated when you start a new C++ dynamic library project in Visual Studio. It creates that DLL main method, and then it creates a switch for you. And one of the cases, DLL process attach, you can put whatever code you'd like in there. So I'm calling execute calc. And on the right, you can see my execute calc method is just creating a new process with that API call of calc.exe, right? Very basic to kind of prove code execution. But you can imagine that there's a lot of things you can put in here. You can do any kind of tricks to sort of obfuscate your code and load your malware however you like in this DLL. I have a demo here where I'm going to kind of show you just sort of what this looks like. And to kind of preface, on the left here, I have calc.dll, and that is that DLL I compiled. The only difference is, yes, that's correct. This will only work on the Windows version of Office. Calc.dll is just that DLL that I showed you, and it does have one exported function that I added, and the exported function is just to execute it. It's just to call the execute calc function to kind of show you. I'm going to show you that it's a normal DLL, basically. So let me go ahead and play this for you. So you can see on the bottom right, I'm going to just use run DLL to execute the calc.dll file, and I'm going to call the exec exported function, and it's going to pop calc for me. Now I'll copy this into that Word startup directory, and I will change the extension there. And as soon as I open Word, it will open the calculator. And so what's kind of important to note here is that there's no pop-up to enable content or enable macros. This is something that just sort of happens. Microsoft kind of trusts these locations, right? Or the trusted locations. It sort of trusts them as places that the user is accepting any code execution from there. Since this is sort of a post-exploitation, they're not looking for users to allow the execution, right? One thing that you're going to see in my other demos, not in this one, is there's going to be pop-ups for like activate Word. So just to keep in mind, it's because this is in my test environment and I don't have a Word license, or excuse me, an Office license for that. So something to know, you'll see those after this demo. So, okay, I mentioned that in Office, or excuse me, in Excel specifically, you can't use XLL files without modifying the registry, right? But what you can do is use a different kind of add-ins for Excel called XLAM add-ins, or XLA for older versions, right? I'll talk about kind of what the process relationships look like in a little bit, but yes, the parent process is always going to be Word. And so in this case, actually, it's going to be running in Word. It won't even be a child process. Excel can execute code at startup without a registry modification, and that's if you use these XLAM add-ins. And so the way to create an XLAM add-in is on a separate machine. You'll open Excel and you'll add a VBA macro to it. And then when you go to save it, you'll change the type as Excel add-in, right? And that'll give it the extension XLAM. And so you have to put these in a trusted location. That is the directory that typically works on Windows, but you can always query it at that registry key. And kind of interestingly, there's actually a similar feature in PowerPoint where they have PPAM files But this is disabled in the registry by default and requires a change. So once again, may not be the best decision in most environments, but it's good to know that it exists because they may be using PPAM files. You may be able to write to the registry without notice, right? And so it's nice to know that that exists. So just to kind of show you, this is a really basic macro, right, to execute calc.exe, and that's going to be my example all day, pretty much, is executing calc.exe. But you can do all kinds of things in VBA macros as well. So it's definitely, I'm kind of like Deep Six said, you can definitely write code that will inject into other processes or will spawn new ones or whatever you like. The registry key, if you're interested, you can go back to the slides on my slide about WLL. It's that same registry key, but it uses Excel instead of Word. So for this demo, same kind of thing. I have an XLAM file. I'm going to open it first and kind of show you what happens when you try and open this file without copying it to a trusted location. And then we'll copy it to the trusted location and try it again. So let's go ahead and play this. If I open the XLAM, it's going to prompt me to enable macros. If you enable the macros, you get the calc.exe pop-up. And then if you copy it to the trusted location now, and I open this again, and just open normal Excel any document, it's going to pop calc for me without having to enable any macros. In addition to add-ins, there's also another persistence method called document templates that we can use. And document templates are nice because there's actually a way in group policy to block add-ins for Office. And so you can block all of these XLL and WLL add-ins, and I believe even block the Excel XLAM add-ins as well across an environment, right? But document templates, I don't know of a way to block with GPO like that. And so these files can be used similarly to execute VBA code when Word or Excel opens. The difference here is that WLL and XLAM add-ins will execute whenever Word opens or Excel opens. These have to open a document, any existing or new document. It's pretty common when users open Word or Excel to open a document, right? So it's not a huge barrier, but just something that's important to know is that your code may not execute if they just open Word, or if you just spawn a new Word process, maybe it's not going to execute, right? It's got to open for the user and then open a document. Now, the default templates for Word and Excel should be at these two different directories, right? So you have, for Word, that normal.m file actually exists by default, and then the Excel personal.xlsb file does not exist. So you'd have to overwrite normal.m, which by default is just a blank Word document, or you'd have to create personal.xlsb. When you place something here, right, you're going to get that code execution. So in this demo, I have 4 documents on the left, right? I have document.docx and spreadsheet.xlsx, and those are just normal spreadsheets and documents with no macros or anything. And so document.docx and the spreadsheet just have some like plain text in them. And then I have the 2 different document templates that each have that same calc macro that I used in the XLAM example. And so I'm going to kind of show you. You can see that normal.m exists by default there, and whereas the personal.xlsb does not. I just get the product key pop up, but no calc when I open that. But then I copy normal.m, I overwrite it, and I'll reopen the document.docx, and I'll get the calc pop up there, and the product key. The same thing will happen for the spreadsheet, right? I'll open the spreadsheet, and then there's nothing to see here, and then I'll go ahead and copy personal.xlsb, and one more time, open the spreadsheet and get the calc pop up. So one kind of thing that's kind of interesting to note too, the calculator process in this case will not exit when you close Word or Excel because I actually use create process. But yes, if your code was running if you just executed some code instead of creating a new process, it would die when Word or Excel died. That's correct. One thing that's nice about these Office persistence methods, right, is they're great just typical persistence methods, but they're also kind of an interesting way to utilize roaming profiles in an Active Directory environment. If you're not familiar, roaming profiles are just a way to store a user's home directory typically in a file share. And that way, when they log into different desktops around the environment, they get their same documents and desktop and all these things. And so because these are all in %app data %, and that directory is in your home directory by default. And so if you went to a new workstation and opened Excel or opened Word, you would also get code execution on that workstation. So that's kind of an interesting added benefit, I guess, to using this technique. So some notes on detection. In my opinion, the kind of most obvious point of detection here is the file write to a trusted location, right? You have to write to a directory, and these directories are enumerated in the registry, or excuse me, are enumerable in the registry. And so you can use something like sysmon with event ID 11 for file create to look at any files that are created in these directories more closely than maybe other files, right? And so, of course, users may have add-ins or document templates, especially document templates, I think are a little bit more common, but I could be wrong. And so it's not like a guaranteed detection if something is written here, but it's definitely something that would be more interesting than, writing a file in just the desktop or something, because you can look for the macros that are being spawned by those processes and looking for, things like network traffic from Word and Excel, and looking for arbitrary DLL or like odd DLL loads from those applications, right? And so this is something that if you have at least an EDR or something, it's probably monitoring. If not, there's other ways that you can sort of monitor process spawning and library loads, again with sysmon. But those are kind of the points of detection for these sorts of things, at least from my point of view, right? Like I said, I'm not someone who necessarily writes detections, but this is kind of where I see it being potentially detected. Okay, so the next thing I want to talk about is lateral movement, right? And technically, we're only going to talk about, I guess, one MITRE ATT&CK item, but we are going to talk about 3 different techniques that you can use for lateral movement. If you're not familiar, lateral movement is just moving from one computer to another, and that's using a already compromised session or set of credentials. So we're assuming that you already have valid credentials on a remote workstation, and you want to execute code on it to get a second implant of some sort, or at least new code execution on another workstation. So before I can talk about the specific lateral movement methods, I want to give you just a quick overview of COM and DCOM. And so one kind of important thing is that this is not a COM or DCOM talk. That's a totally separate, very complex topic that we just don't have time to totally dig into. My hope is to just give you a sort of broad enough understanding to see how we can use COM for lateral movement with Office. So COM is just this programming standard, more or less, that sort of helps developers create binary interfaces in their software. So they create these endpoints that other applications on the system can interact with. And so there are many different components of Windows that use various COM components. And basically, it's just something that's been around for a very long time in Windows, since I think the 90s, to allow different applications to communicate with each other. And on top of that, you then have distributed COM. And distributed COM is just a way for applications on different workstations to interact with other applications, right? And so now from workstation 1, you can interact with an application over COM, right? I'm using DCOM to instantiate COM components on other workstations. With that, we can kind of talk about some different ways to utilize COM to move laterally with Office, right? So in addition to COM, there's actually another feature of Windows called Direct Data Exchange. And this is a feature that's even older than COM. I think it's from the late 80s in Microsoft. And so DDE is just another inter-process communication technology that exists. And Excel can use DDE still today to load data from a server dynamically. So if you have an Access database, for example, you can use DDE in Excel to dynamically update that data in your Excel table as the database is modified. And there's lots of other ways to use DDE legitimately, but there's also ways to use DDE for lateral movement, right? So DDE is something that's only exposed on the workstation, but the Excel.application COM component has methods that are exposed over DCOM to interact with DDE. So basically, we can, through the Excel.application DCOM component, we can interact with this DDE initiate method to execute arbitrary command lines. Here, I'll show you, I've got this sort of PowerShell snippet where first I'm instantiating a new instance of the excel.application com component on the local workstation. And if you wanted to do this remotely, you would just, after the excel.application, you'd put a comma and then the name of a workstation, and it would use your current session to instantiate it on that machine. And then I'm listing any methods that component has that include the string DDE. And then I'm calling DDE initiate to execute command.exe, and for the parameters call calc. Now there are some sort of limitations to using the DDE initiate. There's, I believe, an 8-character limit for the first argument, right? And you don't have to pass .exe to it. So CMD works, for example, but PowerShell does not. Then I think there's a 1024-character limit for the second argument. So you could use command.exe to spawn another binary, say on a file share or something, right? You could use this to spawn other processes that are more valuable than just command line applications, but it will be, I guess, the process relationship will be Excel and then spawning CMD and then spawning something else, which obviously is not very typical of Excel. So besides DDE, right, a DDE is great, but you can only execute command line, which is not great, right? So another thing that we can do is use Outlook. I think I saw a few people asking in Outlook. So Outlook has another COM component called Outlook.application that is exposed by DCOM. And the Outlook.application has many different methods, including one called shell execute. Or no, it does not. I'm sorry, that's totally incorrect. It has several methods. One of them is create object. And create object is a very interesting method because it can be used to execute other COM components on the local system that aren't necessarily exposed by DCOM. So create object can be used to spawn something like shell execute, or even better, something that Matt Nelson from SpectreOps discovered is that you can use it to execute script control. And script control is interesting because you can pass it a VB script or JScript payload and execute that. And so now you're using Outlook to, without writing to disk on either system, execute arbitrary VB script or JScript. And so that's pretty nice, but I'm not sure about you, but I personally don't really like writing code in VB script or JScript, right? And that's not a very pleasant experience most of the time. But you can use something like Gadget to JScript, or previously .NET to JScript, to convert just any .NET assembly to VB script or JScript. And so what that means is you can take any C# project that you have, right? And you can write your shellcode loader or some post-exploitation tool or anything you like in C#, or like build that as a .NET assembly, and then convert it to VB script or JScript. And so this is a great way that you can now execute just arbitrary C# code on a remote endpoint without writing it to disk or anything. One kind of interesting thing, I had heard about Outlook.application before this, but one that I had not heard about until just recently was that Visio actually has a very similar DCOM component with a method that's named create object, and it'll do the exact same thing. You can also use Visio to call script control. And so Visio is obviously not included in the basic Office install, but there are plenty of organizations using Visio. And if you identify a certain group of users or workstations that have Visio installed, this might be an interesting way to avoid detections that are specific to Outlook spawning processes, right? Or Outlook detections, right? And so Visio is not as universally accessible to you like Outlook might be, but it's definitely a nice kind of tool to have for you because it might come well in handy if Outlook.application is getting detected. So to try and simplify this a little bit, again, here's a PowerShell snippet of me doing this. And all of these examples that I do in PowerShell, you could also write in C# if you prefer, right? Because a lot of times C# is better for post-exploitation OPSEC now than PowerShell. But I just do this because it's kind of a much shorter example to show you. And so first, I'm creating a new instance of Outlook.application. And in this case, it's on the local machine, but it could absolutely be on a remote one. And then I'm looking for any methods called create object. There's only one. I'm then creating a new instance of of create object and using that to call script control. And then I'm setting the language to JScript, and then I'm passing it this code variable, which just contains the text of the script. So to try and clarify this a little bit, you can see there's Outlook.application, and it's calling create object. And then create object can call any arbitrary COM component. And so create object is then calling script control, which is a different COM component entirely, and that has a method add code that we're using to execute VBScript or JScript. The last lateral movement technique that I have to show you revolves around XLM macros, right? So XLM macros are this sort of alternative to VBA macros that you may or may not have heard of before. They're very old as well. They're also referred to as Excel 4.0 macros, and they're a totally different language than VBA, and I'll show you an example in just Excel in a second. Historically, XLM has been really difficult for us security vendors to detect on. Now they've added AMC integration in the newest version, and so it's definitely becoming easier to detect, right? But AMC is not, of course, a silver bullet, right? And we've seen plenty of examples of bypassing AMC online. So XLM, similar to VBA, can be used to make Windows API calls, and these can be accessed through a DCOM method called execute Excel for macro. The Excel.application, that same DCOM component, has another method called execute Excel for macro. There's a C# tool from Reverse Shell called sharp Excel for DCOM, and there is a PowerShell script that came out before that called invoke Excel for DCOM from Outflank. And both of these can be used to combine the fact that you can execute API calls with the fact that you can do this totally in memory over DCOM to execute just arbitrary shellcode that you pass to these applications on the remote host. This is just a screenshot that I took from that original Outflank's blog where he talked about invoke Excel for DCOM. And you can kind of see what these look like. First, you're sort of registering the virtual alloc API call with the name valloc, and then you're calling valloc with a large buffer, and then you're registering write process memory, and finally, and then you're sort of looping through and calling write process memory once per byte in the shellcode array, and that shellcode array is stored as char variables over in column 2. And then once that loop finishes, you're finally just going to call, well, I guess, are you going to register and then call create thread and start a new thread in the process. And so that virtual alloc write process memory create thread sort of set of API calls are, of course, very suspicious, but they're just kind of the most basic example of, I guess, just code execution in the same process, right? So you're just passing it that shellcode array, and you're going to execute it now. And so in this case, you have to put it in an Excel spreadsheet, and you can send it as a .xls, I believe. And then if they enable content, it'll execute. And that's kind of interesting and can be used for phishing, of course. But what we can also do, and kind of bear with me, I know this is a lot on this slide. This is some snippets from the sharp Excel for DCOM program from Reverse Shell. And I just want to kind of show you that this is doing the same thing. You can see those first two lines, they're instantiating a new instance of the COM component, Excel.application, and we're passing the computer name, which is the name of the remote workstation we want to execute this on. And then those next three lines are invoking the execute Excel for macro method one time to just call virtual alloc without registering it. And they're only giving it the length of the shellcode variable as the buffer size. And then again, they're going to loop through and just keep calling write process memory once for each byte in the shellcode array. And then finally, once the entire buffer has been written, they will call create thread to kick off the code there. So I'm going to have a demo here to show you what this looks like. On the left, I have workstation 01 that I'm RDP'd into, which is going to be the host that I've compromised in this example. And on the right, I have workstation 02, which is the host that I want to move to. And I have an account that has credentials on that machine, and I've just left open Process Explorer there. So we can sort of pause the demo and sort of look at the process relationship so you can see how this happens, right? In the command prompt here, I'm just going to execute sharp Excel for DCOM. I can find my mouse. I'm going to give it computer name 02. So the first thing that happens, you see excel.exe is spawned here. But if you look closely, assuming you can read the text with how tiny it is, it's a child of svchost.exe. And that's because it's actually being spawned by the DCOM launch service. And so that's kind of one indicator, right, is that Excel is being spawned by a service instead of by some user from Explorer. And then it'll kind of take a second as it's writing that buffer, in my case, just a calc.exe shellcode. And then you can see calc.exe is being spawned. In this case, it's a sub-process, right? And Excel is going to die because the instance is no longer needed once sharp Excel for DCOM is done with it. And then calc will just be underneath the SVC host in sort of this program here. And so kind of going here, let me just let it play out, and you can see the calc pop up there. Now, I called Sharp Excel for DCOM as an exe on disk, right, on workstation 01. Because it's a .NET assembly, you can execute this with something like Cobalt Strike's execute assembly, so that this isn't something they're writing to disk. And then in that scenario, you'd be doing this totally without writing any files, and you're not creating any new Excel spreadsheets, and you're not spawning anything that the user can see necessarily, except obviously calc, but you wouldn't spawn a GUI application, I guess, in the actual use of this. So let's talk a little bit about detecting this. So first of all, I already mentioned that XLM has AMSI implemented, but so do VBScript and JScript. Anytime you're executing XLM macros or VBScript and JScript, that's all being scanned by AMSI, which of course is not a silver bullet, but it is definitely a start, and it's going to catch many things out of the box especially. The other thing that's kind of interesting to me is that Sharp Excel for DCOM and Invoke Excel for DCOM, they both use these same 3 API calls. And I know that part of that is because writing API calls in XLM format is kind of confusing. I don't want to say confusing, but it's different than writing them in just like C or even C#. Or you've got to kind of read a lot of documentation, I think, and a lot of these probably aren't even documented. But all of them are using those suspicious API calls. And those are going to be the kind of things that are almost for sure going to be hooked by your enterprise monitoring software, like EDR, right? Because those are very commonly used for process injection and for code execution. And so even I think the Windows Defender behavioral monitoring looks at those now. So that's something that will almost for sure get caught if your buffer is suspicious enough, right? But not to say that you couldn't modify these tools to use different API calls. In addition, all of these techniques use COM, right? I told you at the beginning. And because of that DCOM launch service will always be the parent process. And in addition to that, it's kind of an added indicator. You'll have the DCOM launch process, and then they will also, because they're sort of listening on the network to get instructions, right, over DCOM, they're going to have a socket listening on a high port. And then they're also going to be launched, if you want to look at something like Sysmon, you can look at the command line flags from when they're started. The Outlook and Excel, when they're launched, are going to have that TAC embedding flag, and Visio will have /automation TAC embedding. And so this is something that when you just launch Excel or Visio or Outlook from the desktop, they're not going to have those command line arguments. Now, you may enter environments where they're using these features for actual business purposes. I don't know of how exactly you would use those for legitimate purposes, but I'm sure that there are ways to do this, right? Or I guess reasons to do this. So not saying that you can't use them because of these detections. It's just something to kind of keep in mind as an attacker and to sort of look into, I guess, as a defender. So lastly, I want to talk about credential gathering. And credential gathering is really just the process of collecting hashed or plain text credentials, or even user sessions, I guess, but really just hashed or plain text credentials for users in the domain. And the reason you do this is because as much as you innovate on a workstation, right, even if you become system privileges on some arbitrary workstation, that doesn't really grant you elevated permissions in the entire domain. And so eventually you have to try and compromise credentials for users who have more permissions than you across the environment. And so that's kind of where credential gathering comes in handy. One very common practice for us on internal pen tests is to do net NTLM credential gathering as well as relaying, right? And so if you performed maybe an internal pen test, you might have had like a Kali machine that you put on the customer network, and then you run something like Responder with net NTLM relay, net NTLM relay X. And those two tools combined will sort of respond to a request for various things and then relay the authentication credentials that are sent. And this is a very useful approach, right? Depending on the environment, this can be a very useful way to gain new access to systems, but it requires administrative privileges often on the host that you want to listen on, right? And so for an internal pen test, this is great, but for something where you're operating without a machine on the network and you've just compromised some workstation with a low privilege account, you can't necessarily listen on port 445 because that's for SMB and it's a low port, so it requires administrative privileges to listen on. There's recently, though, been some research into other services that can be used to listen and require authentication from users. And one of them is using a WebDAV server. So you can host a WebDAV server on an HTTP port and run a web dev server with HTTP, and you can run that on any port you want. So you could run that on any high number port that doesn't require high level permissions. Now, there's a few caveats to this. Unlike SMB, the server must be on the same local intranet zone as the victim. And local intranet zone is a definition by Microsoft. You can look it up if you want to know the specifics. But what it really means for us is that we need to be on the same local network and use the listening host's NetBIOS name in our sort of path. And if we do that, we'll be considered in the local intranet zone, and we'll be able to ask for credentials successfully. You're probably wondering now, okay, great, we can listen on HTTP, but how do I do that? And one way that you can do this, MDSec recently put out a toolkit called Farmer, and one of the tools in it, called Farmer, is just a .NET assembly that can listen on whatever port you want for as long as you want and require credentials when users connect. Farmer is great because, again, it's a C# project. You can run it with execute assembly, so you're not writing it to disk, but you can also start that listener, and you can have it just run in the background for as long as you want. Now, to run this, right, we have to find a port on the host that will allow inbound connections. And so depending on the local firewall configuration, we may not be able to listen on random high ports. So there's a tool from SpectreOps called Seatbelt. It's very popular for enumeration, and one of the commands in it is Windows Firewall. And that's a great command for this specific scenario because you can get a list of all the default policies as well as any exceptions that you may be able to use. Now, more interestingly, there's a researcher at CrowdStrike at Ninja Paranoid, and he tweeted basically that you can actually listen on sometimes privileged ports without administrative privileges. And the way you do this is you actually list the whitelisted URIs. And you can see that command at the bottom, netsh http show URL ACL. And if you run that on just your Windows computer, you'll see what the whitelisted URIs are. And one of the default whitelisted URIs is actually everyone on a system can listen on port 80 if they append temporary listen addresses like that to their listener. And so that's another way that, again, in the default configuration, you may not be able to listen on some high port because of the firewall or even just because of OPSEC considerations, but you can listen on port 80 with this sort of string appended. Now you're thinking, okay, that's great, but I have to prompt users to browse to an HTTP server and enter their credentials. That's not really forcing, credential gathering like Responder is. And so once you have the HTTP listener running, we can force authentication in a couple different ways. The first way is a tool from NCC Group, and they're another group that was researching the same kind of topic, and I think they published maybe a little bit before MDSec, but again, right around the same time. And they released a tool called SigWhatever, and SigWhatever is kind of an alternative to the Farmer toolkit in that it will spin up the HTTP server, it will prompt for authentication, it will present you with hashes, right? But if you want to, you can just use the Farmer tool as an HTTP listener and then use SigWhatever to sort of add these 1x1 pixel images into the current user's signature block. And that 1x1 pixel image is not visible, and what it'll be is actually a link to a file that doesn't exist on your HTTP listener. So when that user's signature is loaded, Outlook will try and fetch the image, and to do so, it will authenticate to your HTTP server. So you can either start manually sending emails as the user the backdoor, which is probably a little bit noisier, or you can just kind of wait for them to send internal emails, which of course isn't an unusual behavior by any means to send emails in the environment. So either way, you can sort of force authentication with Outlook this way. Now, in addition, we can force authentication with Word in a sort of different way by putting new hyperlinks in existing documents. So this is something that's interesting because what you can do is you can actually put these links in documents that are on things like file shares that you see like recent edits on, for example. By putting it there, you just wait until users go to open those documents and you'll start getting authentications. This is a little bit more obvious because, as you're going to see in the demo, it does put text in the document because it has to put some text to hyperlink. And so it's a little bit more obvious, but it is something that you could put something that seems real, right? It's not like you have to put HTTP forced authentication or something. MDSec in that same toolkit has a .NET assembly called Fertilizer. Fertilizer is something that can be used to poison existing Word documents. Right now, it's Word specific. they point out, that you could easily, or maybe not easily, but it could be quickly ported to other document types. I kind of took a look at it. The library they're using does have support for other document types, but it's not something that's as easy as just changing Word to Excel. You'd have to do a little bit of work to figure out what the the Excel or PowerPoint specific elements were. But for now, you can poison Word documents, so that's plenty. Okay, so I have a demo here. At the top left, I'm going to start a listener for Farmer on port 8080. I'm going to then, at the bottom, I'm going to spin up Fertilizer to poison document.docx with the text important info. And then we're going to open the document and see what happens. So let's go ahead and play this. I'll spin up the Farmer listener so you can see what that looks like. That's listening on 8080. We've got the poison document. It's now pointing to the test file, which does not exist. This pop-up is really interesting. The yes or no, do you want to load content? I didn't show this in the demo, but either way, if you click yes or no to load the content, it's still going to authenticate to the server. And so I'm not really sure what the purpose of that pop-up is from a user security perspective, but it doesn't stop this authentication from happening. That was kind of an interesting note, I thought. Okay, so detecting this. The problem with this technique is that it doesn't generate a ton of indicators, right? The network traffic that's happening is maybe a bit odd, but it's not necessarily something that's totally unseen. There's not any weird processes created on the hosts besides, of course, spinning up the listener and the tool to poison documents or signatures. One thing that you can do to protect from this, right? First, you can disable Outlook's automatically downloading of images. And so I think the default configuration is it will not download images from external emails, but you could also disable it for internal emails, and that would stop SIG whatever. As far as the fertilizer attack, really the best defense is to just tighten down host firewalls, right? And so if you just tighten the allowed ports for users to listen on, right? Because most users don't need to listen on ports very much. And so if you kind of tune that more to your environment, that's the way that you could stop this. All right, so with that, that's kind of all that I had. I'm going to start looking through and making sure there weren't any questions, I guess. One kind of, hate to plug one more time, but if you enjoyed this, right, I'm going to be giving a sort of Windows post-exploitation, not Office-specific course that's going to happen virtually May 24th through 27th, and then in June, the 16th through the 18th in person. These are going to be 4-hour sessions. We'll cover enumeration, persistence, privilege escalation, and lateral movement. And for each of these, we'll talk about how to use the techniques, what exactly they do as far as impact on a system, and then from that kind of talk about the OPSEC implications of each. We'll use open source tools, but we'll also write custom implementations for some in kind of labs. So I've got a shortened link there that you can use. But with that, I'll leave that up while I kind of go through some questions here. Can you kill the service before? I'm not totally sure what you mean. I guess if the listener was killed, yeah, you would not get the credentials. Are farm and fertilizer detected by common antiviruses? I'm sure at least the binaries are absolutely detected by common antiviruses, but if you're running them in memory like that and you take some efforts to obfuscate them, probably going to be difficult to detect those specifically, besides maybe the fact that they're listening. Thank you guys all for coming. I'd love to see you guys in my class, whether virtually or in person.
Kyle, that was a great talk. Thank you so much for agreeing to be with us today.
Yeah, glad to be here.
And it looks like you're getting a ton of great response, Kyle. So clearly we got to have you come back for another
Awesome.
podcast.
You're always welcome.
I was just looking through some of the questions on actual GoToWebinar.
Oh,
yeah.
There was one, it looks like it was pretty early on though. It says, hopefully there will be recommendation at the end that will mitigate all these open doors. I don't know if you went through that during your presentation or not, or if you want to speak to that at all.
Yeah, so I touched on kind of some starting places for detecting these things. Again, I'm not necessarily someone who writes detections. For some of these, there are ways to block them with GPO, like I mentioned. I think someone mentioned the Attack Surface Reduction Rules, ASR, which is a free, I believe, GPO implementation from Microsoft, which is a great way to block a lot of these techniques And that's the way that you can block things like unsigned macros or block I believe you can block suspicious API calls or something like that from macros. So that's a great way to stop a lot of these techniques as well. So definitely something that I recommend looking into from a defensive perspective. But yeah, I kind of hope to give as much guidance as I could from a defensive perspective. I also listed the MITRE attack IDs, and they also have lots of documentation on how you might get started with protecting those.
Do you touch on SharePoint in your class?
I don't spend a whole lot of time on SharePoint in the class. We're mostly focusing on features of every Windows install pretty much. And so we'll focus on things that are installed either in all workstations or all servers or both. But that's something that I could probably talk about as well if people have specific questions during the class.
It says also, have you ever looked at the proxy settings within Office? It does give a different user agent.
Oh, I didn't know that actually. That's interesting.
And there's another one that says, any realistic potential business impact from ASR rules?
I really don't know. That's something you'd have to test with, I think, depending on your kind of use case of Office. Of course, it's going to limit some features of Office, so it's not going to have no impact, but it just totally depends on how you're using documents, I guess.
And Skywalker is asking, he's bumping the question, could PWSH work as a command here?
Oh, yeah, I saw that. I'm not positive, actually. Maybe. Actually, I haven't tried that.
Thank you again for doing this presentation today. And again, we're so excited about hosting your upcoming trainings, both at the end of May and again in Wild West, Hackin Best, way west in Reno, in person. I'm a broken record. I know I am. We are really excited. And we want to thank everybody for coming out today. This is one of our record-breaking Hackin Cast. And so that's really exciting for us. We're all going to go out and celebrate somehow in our own individual little pods tonight, I guess. I don't know.
Yes, we'll see y'all soon.
Bye.